but that's 30 degrees. So the x coordinate is root 3 over 2, y coordinate is 1/2. That's something you should know without a calculator. Okay. Now, if they already give it to you in expanded form, as such, you need to make sure that it's in the form of the jingle. You may have to rearrange terms here, but this time it's already in the form cosine, cosine, sine, sine, sine. Here, cosine, cosine, sine, sine, sine. Okay. So from expanded form to condensed form, this is the cosine sum or difference identity because it's in the form cosine, cosine, change the sine, sine, sine. So it's going to be cosine of first, this time minus second, because the sign changes from addition to subtraction. The next one here, this is the cosine jingle. The sign is going to change from subtraction to addition. So first angle is pi over 3, second angle is pi over 4. But following our identity, the subtraction changes to addition. Okay. So then we have cosine of first minus second. That's cosine, cosine plus sine, sine. Cosine of first plus second. That's cosine, cosine minus sine, sine. Okay. 23 minus 67 is negative 44. If you have a negative inside, we can simplify. And because cosine is an even function, we can drop the negative sign inside. So cosine of negative 44 degrees is equivalent to cosine of 44 degrees. Let me move that up. Cosine of negative 44 degrees is equivalent to cosine of 44 degrees. And as Stephanie reminded us, cosine and secant are even functions. Sine, cosecant, tangent, cotangent are odd functions. So cosine is an even function, which means that f of negative x is equal to f of x. Okay. Next, when we're working with radians, we should get a common denominator. So common denominator here is going to be, let's see, 12. So the first fraction will multiply top and bottom by 4. Second fraction multiply top and bottom by 3. So we have 4 pi over 12 plus 3 pi over 12. And so that simplifies to 7 pi over 12. Okay, so we can go from condensed to expanded or from expanded to condensed. Any questions before we move to our identity group number 6? Let me check to see if there are any questions before I move forward. Okay, students, thank you for your feedback in the chat, in my DMs. Appreciate that. Are there any questions? Don't hesitate to bring it to the discussion. Thank you, students, for the feedback. Okay, we're good to move forward. So group number 6 is the co-function identities, and this is related to graphing. If you remember in chapter 2, sine and cosine have the same shape for the graph. They're just separated by one phase shift. Secant and cosecant have the same shape. They're just separated by one phase shift. And tan and cotan have the same shape. They're just separated by one phase shift. Therefore, if you take sine and shift it, you're going to get cosine. Tangent and shift it, you're going to get cotan. Secant, shift, you're going to get cosecant. Okay. Now, in addition to the shifting, we may need to reflect it. So let me rephrase that. They're separated by a shift and possibly by a reflection. So by shift and or reflection. But the shape for sine and cosine are the same. Tan and cotan are the same. Secant and cosecant are the same. Basic shape. You just have to either shift or reflect to go from one to the other. Okay. So group number 6 cofunction identity tells us when we go from a function to its cofunction and vice versa, we're going to replace the input with pi over 2 minus input. Okay, so let's say we have sine of pi over 3. When we go from function to cofunction, so when we go from sine to cosine or cosine to sine, tangent to cotangent or cotangent to tangent, secant to cosecant or cosecant to secant, all we need to do is replace the input with pi over 2 minus input. We replace input with pi over 2 minus input. When you're going from function to cofunction or cofunction to function. So let's see what we have here. Pi over 2, let's write it over 6. That's 3 pi over 6. And then pi over 3, that's 2 pi over 6. Get a common denominator. And when we simplify this, we have cosine of pi over 6. So let's check. At pi over 3, 60 degrees, the y-coordinate is long leg, root 3 over 2. At pi over 6, 30 degrees, our cosine is also long leg, root 3 over 2. So you can see that checks. That sine of pi over 3 is equivalent to cosine of pi over 6. And that was applying our cofunction identity. That the function of u is equivalent to cofunction of pi over 2 minus u. Okay, I'll say that again. When you go from function to cofunction or cofunction to function, replace the input with pi over 2 minus input. So that summarizes identity group 6. Okay. Let's see how this is applied in the next page. Okay, so sine of 5 pi over 12. The input, we're going to think of that as u. We say when we go from function to cofunction, we replace the input with pi over 2 minus u, minus input. So sine of u is equal to cosine of pi over 2 minus u. Okay, so that's directly applying our identity group 6 cofunction identity. Okay, let's get a common denominator, which is 12. So we'll multiply the first fraction by 6 on top and bottom. 6 pi minus 5 pi is pi, and denominator is 12. Okay. So now let's go ahead and rewrite pi over 12 as a sum or difference. So let's do it up top here. Pi over 12, that's going to be 3 pi over 12 minus 2 pi over 12. Okay. Because 3 pi minus 2 pi is pi, denominator 12. So 3 pi over 12, that's pi over 4. 2 pi over 12, that's pi over 6. So Esmeralda told us that pi over 6 minus pi over 4 was negative pi over 12. Here we see that pi over 4 minus pi over 6 is going to be positive pi over 12. So we have to find two radian measures that are on the unit circle. Okay, so that was step 1 in our process of getting the exact value. Step 2 is applying the appropriate identity. So let's expand. Cosine sum or difference identity goes as follows. It goes cosine, cosine, sine, sine, sine. So sine, sine, sine means you change the plus or minus sign, then you have sine times sine. The jingle goes cosine, cosine, sine, sine, sine. Let's put in first, second, first, second. Students already helped us with this. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 6, long leg, root 3 over 2. Sine of pi over 4, root 2 over 2. Sine of pi over 6, short leg, is 1/2. Okay. So this one also comes out to be square root 6 over 4 plus square root 2 over 4. The reason why the answer is the same as what we saw on page 1 is because cosine is an even function. So cosine of negative pi over 12 ends up the same as cosine of pi over 12. And if you put in the original sine of 5 pi over 12 into your calculator in radian mode, your decimal approximation should match the decimal approximation for root 6 plus root 2 all divided by 4. Use your calculator at the end to help you check your answers. Okay. So using the cofunction identity, we saw that sine of 5 pi over 12 is equivalent to cosine of pi over 12. Sine and cosine are just split by 1 phase shift. And then earlier we saw that cosine of negative pi over 12 was our answer. Cosine of pi over 12, cosine is an even function. So cosine of input is the same as cosine of negative input. And when we worked it out using the 3-step process, we saw that our answer here matched our answer on page 1, bottom of page 1. Okay. Stop me if you have questions. We have 6 groups of identities so far. I'm going to list them out for us. So I like to keep a running tab, and you should as well on your reference guide. We have the reciprocal identities. We have our tan cotan identities. We have our Pythagorean identities, even odd identities. We've added to the list today sum and difference for cosine and cofunction. Okay. So now we have 6 groups of identities in our toolbox. By the end of the lesson tomorrow, we'll have all 10, but right now we have 6. So students, Try to do the next proof using the 6 groups of identities. Okay. And for this problem, we're going to use the alternative method. So the preferred method is to transform one side into the other. If that doesn't work for your given problem, then we can use the alternative method, which is simplifying both sides and then showing the left side is equal to the right side. Okay, so try this one using the method that the new method we learned at the end of section 3.2. You're going to simplify the left side, simplify the right side. The tools that you have to use are the 6 groups of identities. If you're able to show that both sides simplify the same expression, then you've completed the proof. So what you're going to put in my DMs is put the expression that left side and right side both simplify to. Send that in my DMs, and we'll check to see if we're in agreement. So both sides should simplify the same expression. Write that expression in my DMs. I'm going to pause while we're working. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And as
Recording
we've done,
stopped.
if you have questions, communicate with me in the chat. I assume that we're on task. Once we have simplified both sides, tell me what the expression simplifies to. Okay, I'm getting a couple responses, so we're going to give students a little more time. Remember, if you finish these practice problems early, open up your homework to see if you can get 1 or 2 homework problems done during class time. The next batch of homework assignments are due on exam 2 day. However, we want to space out our work so that we have the homework practice in preparation for the quiz. So we have a quiz today and a quiz on Wednesday. Okay, so let's come back together here. I'm interested in hearing what approach we took. So let me resume.
Recording in progress.
Okay, so I'm going to ask all students to send me a message privately. For the left side, when we see, so I'm going to write it up for us. Cosine of x minus pi over 2. Okay, so I'm interested to see, did we use identity group 5 or 6? So just type that into my DMs, because either way would work here for the left-hand side. We can use number 5 or 6. Which one did we use to simplify the left-hand side? Please share. Sum and difference. Okay. I'm seeing most students use the sum and difference. That works. If we wanted to use the co-function, let me show us what we would do. We would have to switch the order. Remember, we learned as an algebra student, sorry, okay. As an algebra student, we learned that oh, why is it doing that? Okay. We learned that A minus B is equivalent to opposite of B minus A. So if we switch the order, we have to factor out a -1. A minus B is the opposite of B minus A. So x minus pi over 2 is the opposite of pi over 2 minus x. However, since cosine is an even function, we can just drop the negative sign inside. So the negative side inside gets dropped because cosine is an even function. which means f of negative x is equal to f of x. Okay. And then from there, we see that cosine of pi over 2 minus x, that's equivalent to sine of x. Because from function to cofunction, we replace input with pi over 2 minus input. Okay. So we could have gone that route, but from your feedback in the chat, most students saw this as, or use identity group 5, which is the cosine jingle. When you have cosine of a sum or difference inside, we can expand. So it's cosine, cosine, sine, sine, sine. Okay. Put in first, second, first, second. Okay, and then it's cosine times cosine, change the sign, sine, sine. First, second. And so cosine of pi over 2 at 90 degrees, the x coordinate is 0. Sine of 90 degrees, at 90 degrees, the y coordinate is 1. So anything times 0 is 0, and the left side simplifies to just sine of x. Let me pause. Any questions on how we're able to simplify the left side? There are different methods here. We could have used identity group 5 or identity group 6. Using identity group 5, we expand, evaluate, and simplify. Using identity group 6, we have to use some algebra techniques. X minus pi over 2 is the opposite of pi over 2 minus x. Cosine is even. So cosine of x minus pi over 2 is equivalent to cosine of pi over 2 minus x. And then using cofunction identity, so this one is using number 6, cosine of pi over 2 minus x is equal to sine of x. Because sine of input is equivalent to cosine of pi over 2 minus input. Okay, are there any questions? The left side was the one that took a little more work. Okay. Jacob, does it make sense to use 5 or 6? Are we good? I know you had a question earlier in the chat.
That makes sense now. Thank you.
Great. Okay, let's go to Jimmy. Jimmy, how do we simplify the right side? Please unmute yourself.
I got cosine of x, and then it's sine over x over cosine.
Yes. If we can't go anywhere with it, let's change everything to sines and cosines. So we're using identity group 2. Tangent of x is sine of x over cosine of x. Okay. Anything divided by itself is 1, so the right side simplifies to sine of x. Thank you, Jimmy. And so since both sides, left side and right side, simplify to the same expression, we have now completed our proof, and we've shown the left side and the right side are equivalent. Are there any questions before we move to our final page to wrap up section 3.3? So reminder that we do have a quiz today. We have another quiz Wednesday. All together, let's see. So by the end of this week, we will have approached the halfway mark. There are some announcements I'm going to go through, but we'll save that for the end of the discussion, end of class. Oh, yes. Jimmy wants to go back to the first page. Right here. Jimmy, let me know once you've captured what you needed.
Oh, it's the second. It's the second page I need, not the first. My bad.
Okay. This one?
Yeah, let's see what I missed. Okay, thank you.
Okay, great. So students, let's move to the final page. And the final page, or actually any questions here? I want to make sure I don't miss anything in the chat. Okay, so this time just put an R, meaning you're ready to look at the final problem and wrap up section 3.3. Thank you. The R means ready to move forward and lets me know that we're still together. I did have one instance in the beginning of the pandemic where I thought we were still connected and we weren't. And so the students were not getting the lesson and I kept going. So typing in the G for good, R for ready, W for working does really help to let me know we're still together. And the technology is still working. Okay. The last problem is one that we're going to double star, meaning that you're going to see something similar on a quiz or exam, or probably both. Okay, double star. It's an important one for us to review. First reminder is in these problems, when you're given what quadrant the angles are in, that's something that you want to circle and pay attention to. So alpha is in quad 2. Quad 2, x is negative, y is positive. Beta is in quad 1. In quad 1, x and y are both positive. Okay, so you want to find cosine of alpha plus beta. This is identity group 5. Let's expand. Cosine of alpha plus beta, we put in the jingle. Cosine, cosine, change the sign, sine, sine. And then we fill in first angle, second, first angle, second. Okay. So far, they have given us that sine of alpha is 3/5. Sine of beta is 5/13. We're missing cosine of alpha and cosine of beta. Okay. Let me put it this way. So there are 4 values here to fill in. They give us 2 of them, cosine of alpha and sine. Let me say that again. They give us sine of alpha and sine of beta. There we go. They give us sine of alpha, sine of beta. We're missing cosine of alpha and cosine of beta. So they give us 2 out of the 4 unknowns. And there are different methods we can use to fill in those 2 red boxes. So the first method is using the Pythagorean identities. So for this type of problem, you can use Pythagorean identity. I call this the P method. Or you can use triangle method. When we're first learning the Pythagorean identity, we like to introduce that to students. The Pythagorean identity allows us, given one trig function at alpha, we can find any trig function at alpha. However, as we get more comfortable, the triangle method is usually the preferred method. Okay, so let me show us. The triangle method means we're using SOHCAHTOA. Okay. So for the triangle method, let's note that our alpha is in quadrant 2. In quadrant 2, x is negative, y is positive. Regardless which method you use, you have to be mindful of the quadrant. Okay. So using the Pythagorean identity, given sine of alpha, we can find cosine of alpha. We have done this in both chapter 1 and 3. Okay. So given sine of alpha is 3/5, we can apply the Pythagorean identity to find cosine of alpha. But I want to introduce us to the triangle method because later on in chapter 3, this method is going to save us some work. So the triangle method is filling in our triangle. Sine of alpha, remember sine is the ratio of opposite to hypotenuse. So if sine of alpha is 3/5, then in our right triangle in relation to our reference angle, we call it alpha prime. The ratio of opposite to hypotenuse is 3:5. Ratio of opposite to hypotenuse is 3:5. So in the triangle method, we solve for the remaining side. We can do that using the Pythagorean theorem. Okay. So Stephanie, what is that remaining side?
-4.
Okay, in a right triangle, we would just say it's 4 because in the right triangle, all sides are positive.
Oh, okay.
Okay, so this is going to be 4. Use Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. Because in a right triangle, all 3 lengths are positive. Okay, so that means cosine of the reference angle. Cosine is adjacent over hypotenuse. That's 4/5. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So this was adjacent over hypotenuse. However, since we're in quadrant 2, cosine is negative. So since cosine is negative in quadrant 2, actually, I'll just leave that. Cosine is negative in quadrant 2. Cosine of alpha is negative 4/5. That's our first red circle. So cosine is negative in quadrant 2. Okay, so we may not see how this saves us work, but we're going to later see when we have our right triangle, now we can get all 6 trig functions at alpha prime. Sine is O/H, cosine is A/H, tangent is O/A. And then once we have sine, cosine, tangent, we reciprocate those answers to get cosecant, secant, cotangent. Once you have the answers at the reference angle, then you just insert the appropriate plus or minus sign to get the answers at alpha. So if alpha is in quad 2, that means sine and cosecant are positive, everything else is negative. Okay, let's try the triangle method again. Beta this time is in quad 1. Quad 1 is our favorite because we know that everything is positive in quad 1. So that saves us some work. We're given sine of beta is 5/13. So sine is defined as opposite over hypotenuse. Now we want to find cosine. I really like the comment Genesis made earlier that she used a different method than Stephanie, and they both arrived at the same, or both were able to transform one side into the other. Similarly, in this problem, there are different methods to be able to fill in those red boxes. And those different methods can be equally correct. Okay, but let's practice here our triangle approach. So beta is in quad 1. We don't need a reference angle here. We only need the reference angle if beta is not in quad 1. in our right triangle, sine of beta is opposite over hypotenuse. So this is 5 to 13. Okay. Let me show us how we'd find the missing leg here. We'll call this leg A. The reason why this is A is because opposite from beta is B. So opposite from alpha would be A. So to find this missing leg, we do A squared plus B squared is equal to C squared. A squared plus 25 is equal to 169. A squared is equal to 144. Since A is the leg of a triangle, it has to be positive, so positive 12. So you see, we use the Pythagorean theorem to solve for the missing side. Once you have all three sides, then you can get any trig function at beta. So cosine is adjacent over hypotenuse, that's 12 over 13. Adjacent over hypotenuse. Okay. Now, if beta wasn't in quad 1, then we'd have to pay attention to the quadrant or the plus or minus sign. But we know that all 6 trig functions are positive in quadrant 1. So that includes cosine, positive in quad 1. Okay, so this time we use what we call the triangle method to find the missing red boxes. Given sine of alpha, we found cosine of alpha is negative 4/5. Given sine of beta, we found that cosine of beta is 12 over 13. We can do that by using the Pythagorean identity or by drawing a right triangle. Either method is valid. Given one trig function at alpha, we can get the other trig functions at alpha as well. Given one trig function at beta, we can get the other trig functions at beta as well. Okay, so let's finish this off. This is negative 48 over 65 minus 15 over 65. So your final answer is negative 63 over 65. Remember that cosine can be positive or negative. Also, the range for cosine and sine goes from negative 1 to 1. So your answer will always be, for cosine and sine, will be between negative 1 and positive 1. Okay, we have a few more minutes of class remaining. Are there any questions with this double star problem that you'll practice and review on your own? Justin is good. Any other questions or comments here? From what you've seen so far, students, share publicly. You're going to put either P or T. P if you prefer using the Pythagorean identity, like we've seen previously. T if you prefer using the triangle method. So from what you've seen so far, what do you prefer? Given one trig function to find the rest, using P method or T method? Oh, okay. Great. All the responses I saw, we like the triangle method. Great. So triangle method is nice because once you have all three sides of the triangle, you can really get any trig function. One thing you have to remember about triangle method is in the triangle, the lengths of a triangle are positive. You have to insert the plus or minus sign appropriately depending on the quadrant. So that's the one thing we need to watch out for in using the triangle method. Triangle method will give you the ratio, the absolute value of the answer. But to determine if your answer is positive or negative, look at the quadrant. Okay, so this concludes section 3.3. I'm going to stop the section 3.3 recording here.